So today we are going to review what it means to be congruent. We've already talked about congruency. Congruency means that the figure has the same shape and the same size. And the thing that we're going to be doing that's new today is what's called similar figures. So it has the same shape, but not necessarily the same size. And we call those similar. Congruent figures have corresponding parts, angles, and sides that are also congruent. There are a few ways we could prove congruency. Remember we did SSS, SAS, ASA, hypotenuse leg. So there are ways to prove that they're congruent. But right now we're just going to focus on which parts are congruent. This symbol right here means congruent. And then what's important I want you to know, so that means congruent. That means congruent. Notice the symbol for similarity. It looks different. It doesn't have the equal sign. So that's one thing I want to make sure you have in your memory collection. So when I look at this congruence statement, that means that angle A is congruent to angle P. So if I were to look at this, angle A, this angle right here, is equal to angle P, because they're in the same spot. Angle B is equal to angle Q, because they're in the same spot. And angle C is congruent to angle R because they are in the same spot. So that's one way you can find congruent angles. That also means that AB is congruent to PQ because they're the first two letters. So AB, which I drew that too long, is congruent to PQ. So these are the same measurement. Okay, so this symbol just says that the two triangles are congruent, therefore each corresponding part is also congruent. So looking at this, they tell us that a quadrilateral ABCD is congruent to RSTU. And they're asking angle A is congruent to what? Well, if you look here, angle A is in the same spot as R. So we know that A is congruent to R. So I could say this is congruent to angle R. And I will go ahead and put in the angle symbol. Let's imagine that's a less than, or not a less than, but the angle symbol. Okay. Angle C is in the same spot as T. So C is in the same spot as T, so they're congruent. So C and T are congruent. AB is in the same spot as RS. So that means AB is congruent to RS. And I forgot to do angle D. D is in the same spot as U. That's easy. DA. DA would be the last letter with the first letter. So that's going to be congruent to the last letter with the first letter. So DA is congruent to UR. And I would put the little line over it to say segment. ST, the two in the middle, are congruent to the two in the middle. So I'd say ST is congruent to BC. So what's nice is you don't really even need a picture. You could just look at the congruency statement and make true statements. On this problem, we know these are congruent because of SSS. We could also use CPCTC because they tell you that every angle is congruent to every other angle, every segment is congruent to every other segment. And so when we're naming these, if we're calling this triangle XYZ and we start at X, so if we start at X, then I must start at the same one. So which one has 3 markings? That would be R. So I have to start with R. And I could just draw the triangle symbol, but I don't know how to do that on this. Okay. And then they're going to X to Y. So they're going X to Y. So they're going from the one with 3 to the one with 2. So you need to do the same thing. You need to go from the one with 3 to the one with 2. So you put S next. And then XYZ, RST. Now angle Z is in the same spot as angle T, so they're congruent. Angle R, here's R, the one with 3 markings, is in the same spot as X. YZ, here's YZ on top. One with 1 marking, that would be the same thing as ST. And then TS, that would be the same thing as ZY. Remember, if these corresponding parts are congruent, that means they have the same exact measurements. So we have A, B, C, D, E, this first one, is congruent to J, K, L, M, N. And they're asking about J, N. So I'm looking at this, and I'm going, okay, J, N is from here to here. So where would that be on this one? Well, J, N is the first one to the last one. So it's going to be the first one to the last one. That's going to correspond to AE. So I could go find AE. And so then I would say that JN, if I'm trying to find the measurement, it would be equal to AE, which is 22. They ask about DC. Let's see, DC is from here to here. Visually, if you can't see it, I think it's going to be this one, but that's hard for me to see. DC would be the 4th to the 3rd, so it's going to be 4th to the 3rd ML. So where is ML? It's right here. So I was actually wrong. I almost chose this one. So DC, 4th to the 3rd, will be the same from 4th to the 3rd ML. So DC is 17. They ask about KL. KL is right here. So KL would be 2nd to the 3rd position, so it's going to be congruent to 2nd to the 3rd BC. So it would be congruent to this. So KL is equal to BC, which is 12. And then from here, measure of angle D, here's D, so that's the fourth one. That should be congruent to the fourth one, M. So D and M should be congruent. M is 158, so D must also be 158. Okay. Okay. Is right here. K is the second one, so it should be congruent to the second one here. K is congruent to B. So if B is 135, so is K. K is also 135 degrees. Alright, so now let's talk about similar figures. Notice the symbol is different. It just has this symbol. That means similarity. They're similar. Before we had this, that means congruent. So that's very important to pay attention to that symbol to see what's going on. To be similar, that means the sides are proportional. So what that means is that if I were to take AB and divide that by DE, because those sides go together, right? AB goes to DE, that those should all be proportional. That means a fraction. So if I take AB divided by DE, that should equal BC divided by EF, and that should equal AC divided by DF. So look what we have, and notice it doesn't matter if you start small and go to large, or if you go large and go to small, you have to keep in the same order. So what they're trying to do is they're trying to see, are these triangles really proportional? So is 10 over 15, notice they did 10 over 15, equal to 8 over 12, 8 over 12, is that equal to 6 over 9? So you just check every side and see if they're proportional. 10 over 15 reduces to 10/3. 8 over 12 reduces to 2/3. 6 over 9 reduces to 2/3. So because they have all the same proportion, the same scale factor, you would say yes, they are similar. Which we knew they were similar because they told us with this symbol. Here's another example. They tell you that this figure is similar to the figure on the bottom, and they want us to find the length of FG. They want us to find this. Okay, since we don't know what that is, we're going to make that be a variable, x. Okay, so that's going to be our x. And so we're going to set up our proportion. And there's many ways to do this. So we're given 20 and 16. So we're going to definitely use 20 and 16. And then they give us 12, and we're going to find our x. So if we take this divided by this, that's going to equal this divided by this. And so that's what they did. 20 divided by 16 is equal to 12 divided by x. And so now you have your proportion. And then from there, you just cross multiply. You get 20 times x is 20x. 16 times 12. And then you take 16 times 12, you get 192. Take 192 divided by 20, and you get 9.6. Now you cannot be afraid to get fractions or decimals because it's probably going to happen with similarity. But FG equals 9.6 meters. That's the units. So the next problem is just like this. It's the same exact thing. They want you to find the length of RS. So what I want you to do is I want you to try yourself. You can hit pause in the video and keep in mind that you can set up a proportion in many different ways. You just have to go in the same order. So try to figure out what is RS. So go ahead and hit pause, and then you'll see the answer here in a minute. Let's go ahead and look at this. They tell us that NOP is similar to QRS. And so looking at this, I know that OP is going to be proportional to RS because they're both the last two. So OP is proportional to RS. And I'm going to make this X because I need to find the length of RS. And then they also tell me that NP, the first to the last, is proportional to the first to the last. So NP is proportional to QS. So NP is proportional NP is proportional to QS. And so I always check that because sometimes, especially triangles like these, you assume that because they're both on the right that those sides are proportional, but this could very easily be flipped over and it could have been OP proportional to RQ. So that's why I always check with the similarity statement. So looking at this, I'm going to set it up, and it's your choice, but we do know that OP is proportional to RS. We know that NP is proportional to QS. So if I start this off with OP, then over here I need to put RS. And OP, actually this should be OP over RS.